minute.
Okay. Do you want
Okay,
to
cool.
do your bit?
Do we have to do the clapping?
Oh God.
All good to go now.
Okay, go. That's the AI. Just does it all for. There's no editor involved. There's no humans involved now. It's all just.
That is
AI.
really crazy. Cool. Hi Sam, how are you doing?
I'm good. How are you?
I'm good. Just got back from a wedding. That was fun. And yeah,
And you were
April
the
has
MC.
been-
Is that right?
I was the MC and a bridesmaid. It was very
Two
fun.
jobs.
Yeah, for free. I'm cheap labor.
How did the MCing go?
It was hard because I had to speak in both English and Chinese. So
Yeah.
apologies if my English is not very good.
Like one after the other, or
Yeah, one after the other.
I see. So
yeah.
you like translated yourself.
Yeah, exactly. But I've been speaking Chinese for 2 weeks in a row because I was back in Hong Kong, where I'm from. So now I'm switching channels and
When did you
having
get
to go back
To the UK.
2 days ago.
Okay.
2-3
Are
days
you
ago.
jet lagged?
A little bit.
A little bit jet lagged.
Yeah. So if I make mistakes, I
It's a good
blame it on my jet
excuse.
lag and not on my ignorance.
No, there's not going to be any mistakes. Don't worry about
And
that.
how are you, Sam?
I'm good. I'm good.
Yeah. What's going
I'm
on
good.
in April?
Lots of breakthroughs. Science
Breakthroughs.
We had. I always get very excited. It's true about medical breakthroughs, and that's why. And that's what we're going to talk about today.
Yeah. So welcome everyone to the 4th episode of Sam
I
and
can't believe we
Tiff.
made it to 4th.
Yeah. Me neither. But
Most
we
people
did
give
it.
up by now.
Commitment. Yeah, 4th episode of Sam and Tiff Talk Science. And I will start with the first out of 3 breakthroughs from April 2025. And thank you, Sam, for letting me talk about this one. I know you really love this trial. So this was a first-line therapy approved by the FDA in metastatic or unresectable colorectal cancer. And specifically, this is for a subtype of colorectal cancer called MSI high, or sometimes is described as MMR deficient, or abbreviated as DMMR. Yeah. And, it's a very exciting approval because the results were so striking. Basically, it was combining 2 immunotherapies instead of just using chemo. And by using 2 immunotherapies, the response rate was at, I believe, 72% compared to chemo alone, which was 14%. Right, Sam?
Yeah, I want to. Can I show the Kaplan-Meier?
Yes, please do.
So maybe it's better to show it like digitally, but I'm going to show it on the screen anyway. So
Yeah.
So I think the nicest way to illustrate what happened here is through the Kaplan-Meier. Okay, this is not a very practical way to do it, right? But so here we go. So this is what you were just saying. So these are
You can see that gap from like miles away.
right. This is wild, right? So it's very rare that you get a trial which has extraordinary efficacy like this. So these are patients who have, like you said, mismatch repair deficient, metastatic colorectal cancer. So about 15% of colorectal cancers are mismatch repair deficient, and we should, by the way, define that.
Yeah, we will go over that. But for now, what is the Kaplan-Meier and what is this showing?
So Kaplan-Meiers are how usually people demonstrate efficacy of new drugs in clinical trials. So in this one, we're looking at progression-free survival. So if a patient with a cancer either dies or progresses, so progresses from stage 1 to 2 or 2 to 3 or 3 to 4, or
As in the cancer gets worse.
exactly, if the cancer gets worse, then that counts as that the graph will go down. So patients who were treated with chemotherapy, unfortunately, have a catastrophically poor outcome.
Mm-hmm.
Patients
The blue
treated
line.
with
The blue line.
yes, the blue line. Patients treated with doublet immunotherapy, so PD-1 and CTLA-4 immunotherapy, have a drastically improved response, and that is what has led to the approval of this extremely effective therapy, which has, by the way, completely
amazing.
revolutionized
That's
this cancer.
72% versus 14%, right?
Yes, so that really shows the extraordinary efficacy of this medication, and it is going to have life-changing results around the world.
It's so incredible that originally the FDA was planning on approving this therapy in June 2025, but it's so good that they approved it early, 2 months early.
Yeah.
Yeah, and let's go back to the basics.
Yes.
To break it down. So, you mentioned that 15% of all colorectal cancers are this subset called MSI high or MMR deficient. What does this mean?
Do you want to go through that?
Oh yeah, I can go through it as well. Yeah, this is very relevant to what Sam and I studied for our PhDs as well, because we studied DNA repair.
By the way, we should have introduced ourselves at the start. Anyway, it doesn't matter. But we were DNA repair PhDs.
Yeah.
Right? And I actually remember while I was PhDing, these kind of the early stages of these results were coming through and getting published.
Yeah.
And I actually worked on mismatch repair for a little bit.
Yeah, I know. That's why I was like, I should give you the spotlight for describing mismatch repair. And but yeah, so what is mismatch repair? What is MSI, and why does this all relate to DNA repair for those who don't know anything about DNA damage and DNA repair?
So mismatch repair makes sure that DNA replication doesn't make any mistakes. So if you try to replicate DNA, but you do it without any repair going on, then there will be a lot of mistakes. Mm-hmm. And that's what's going on in these tumors. So they don't have mismatch repair, which means there's a lot of mistakes during replication, which means there's a lot of mutations that accumulate in DNA, which then produce mutant proteins. Mm-hmm. And just take the story from there. So that, in terms of why immunotherapy is so effective in these mutant cells.
And also MSI is often a direct result of having a mutation in these mismatch repair proteins.
Yes.
So that's why the terms are kind of used interchangeably. And MSI just stands for microsatellite instability versus the other 85% of colorectal cancer, which is MSS, microsatellite stable. But the MSI cancers, these are very mutagenic. They have many mutations in this region of the DNA called the microsatellite region, hence this categorization. And it's often why people care about this in real world and not just scientists is because in the clinic, as a doctor, you see that colorectal cancers with MSI versus MSS, they present very differently and respond to immunotherapies very differently.
Yeah, exactly. So if there's a lot of mutant proteins, then they end up, and this is your specialty, not mine, but they end up getting trafficked to the cell surface and they get presented as neoantigens. So new antigens that the body has never seen before. Now, if there's antigens on the cell surface that the body's never seen before, it views that as foreign. So it attracts the immune system. And this is what we call immune hot. So it's very attractive to the immune system, lots of T cells coming in. Now, of course, the cancer doesn't want to die by the T cells. So what it does is it uses two mechanisms.
The don't eat me mechanisms.
Exactly. To resist the T cells. One is PD-1, the other is CTLA-4.
Absolutely. And these are what, everyone in the scientific and medical world called checkpoint inhibition, when you block these don't eat me signals. And the most popular one is obviously PD-1 inhibition, but there's also the CTLA-4. And going back to this trial is, the sun's come out. That's great.
Distracting.
Currently, the singlet immunotherapy exists for these metastatic MSI high colorectal cancer patients. But no one has ever done a doublet immunotherapy treatment in this setting. And this phase 3 trial is for, to our knowledge, the biggest trial studying a doublet immunotherapy in this setting. And the results are, beyond what they would imagine.
Yeah, absolutely. It's the only trial, from what I'm aware, it's the only trial. So the trial actually has 3 arms. I know the Kaplan-Meier earlier that I showed had 2 arms. That's because it's immature data from the same trial, which then became mature. So we got more data.
So there were 3 groups of patients. Correct me if I'm wrong, but there's the chemotherapy alone. And then there's the singlet. So just one immunotherapy against PD-1. And then there's a doublet immunotherapy that's against both PD-1 and CTLA-4. And yeah, you showed us the results just now for doublet versus chemo alone.
Yeah, that's right. That's right.
But the results for singlet versus doublet were also pretty promising, right?
Very impressive. Do you want me
Yeah.
to show them?
Yes, please. Let's pull up the Kaplan-Meier again.
Okay, the Kaplan again. Well, maybe I'll do a digital version of this. But so if you imagine chemotherapy is down here somewhere, right? This one is singlet immunotherapy. So this one is PD-1 inhibition on its own, and the blue one is doublet. So PD-1 and CTLA-4. So you can see there's two things are clear. So one, PD-1 inhibition on its own beats chemotherapy. Two, doublet immunotherapy beats singlet immunotherapy. We should say that doublet immunotherapy is associated with more side effects. So that's the price. The price you pay. So you have much better progression-free survival, but more side effects.
And that makes sense, right? When you use two immunotherapy agents, there's going to be way more side effects than using just one.
Yeah.
But the good thing is, I saw that for the side effects for doublet versus chemo actually had a much higher percentage of adverse events compared to doublet.
That's right.
So that's
which
great.
is fascinating, right?
Yeah.
So not only is it much better to kill the tumor, but also fewer side effects
Yeah.
than chemotherapy, which is fantastic, right? Then that's an amazing progress.
Yes, probably another reason for why the FDA approved it so soon.
Yeah.
But an interesting point was, so actually not all the patients, I believe, in the trial were MSI high. They were suspected to be MSI high, but there was a very small subset who weren't. And they showed that those patients, their progression-free survival dropped off a lot sooner than those who were MSI, which shows the importance of knowing which patients you're recruiting or like in the future treating, right?
Absolutely. Yeah. Colorectal cancers that are mismatch repair deficient are extremely sensitive to immunotherapy, but they're resistant to chemotherapy. And patients who have mismatch repair proficient tumors are much more sensitive to chemotherapy, but much less sensitive to immunotherapy. So in other words, you've got to be absolutely sure what the status of the cancer is before you treat it.
I didn't know that. So it's absolute inverse.
Absolute inverse. Exactly. Yeah.
Wow.
So and which illustrates your point, right? You've got to be so sure before you treat. Are we treating mismatch repair deficient or proficient cells here?
Yeah, and there are different ways of testing, and this really shows the importance of accurately testing for MSI status.
Yeah.
And this is all, we're all moving towards an era of personalized medicine, and these are just like things that we have to consider.
Yeah, absolutely.
Yeah.
Can I say one more thing about this, or do you want?
No, you go ahead. You go ahead.
Okay, one more thing about this. It's actually about immunotherapy in colorectal cancer, mismatch repair deficient colorectal cancer. So there's two different types really. This is metastatic that we've been talking about. So this is when it's spread.
Yeah.
But there's a different type of the cancer, which is when it's still local, right? So it's not yet spread.
Yeah, that's a good point because this trial is specifically for the metastatic or unresectable CRC MSI high.
Exactly. And so usually if you've got a mismatch repair deficient tumor, which is still local, you would opt for surgery, right? But new data, also from April, by the way, nice.
Oh, nice. We should have thrown that in there.
It turns out that if you use immunotherapy, so PD-1 inhibition for 6 months, then in many patients, sometimes even in every single patient, you can evaporate the tumor. The tumor dissolves, it's gone, which means there's no need for surgery.
Wow.
And if there's no need for surgery, that means you spare the complications of surgery, which can be bad things and also kind of less severe things like nerve damage, this kind of thing, pain.
Yeah.
You also it means that you can preserve the organ, right? So you don't have to take out any of the organ, which means, so if you're talking about the colon, it means the colon can retain its function as the bowel.
Yeah.
And it means you can spare having a stoma, for example.
Yeah.
So immunotherapy is so effective in some local mismatch repair deficient colorectal tumors that it can spare surgery completely.
That is incredible, like a really high complete response rate.
Exactly.
Complete response meaning the tumor just completely goes away, especially before it's spread to different organs. Exactly.
And so for the rectal tumors in the trial, there was something like 25-30% patients with rectal tumours that were mismatch repair deficient,
Mm-hmm.
every single one of them, 100% of them, had a complete response. So an absolute evaporation of the tumour with immunotherapy.
You know, you brought up a really interesting point just now because I didn't know this as a scientist, but when I started speaking to clinicians, I realized that even though we keep calling it colorectal cancer, colon and
Oh, yeah.
rectal are apparently like treated really differently in the
Yeah.
clinic, and I had no idea. So yeah, when you made that differentiation, I just
Yeah.
thought of that.
Yeah, I think they can have very different drivers. They can act very differently. They can spread to different places. They're differentially aggressive. They're treated in different ways. They're monitored in different ways. So it's true that we kind of think of colorectal cancer as kind of one entity.
But actually,
and
colon and rectal are two different like conditions in the clinic.
Exactly. And to be honest, even if you go with different types of colon tumor, so if it's in the ascending colon, the transverse colon
versus a descending.
Exactly. It's different again, even between those, right?
Wow.
So, yeah. I guess it shows your point, right, about personalized therapy. It's each patient, each cancer is so different from the last.
Exactly. You have to look at the DNA mutations. So whether it's MSI or MSS, and then you have to look at where the tumor is, physically.
Yeah.
Yeah. It's all coming together, I think. All really good efforts by the whole community. Awesome. Anything else from this study? Really good news.
I don't think there's anything else I want to say about that, but that's fascinating. The only thing I have to say is that it's awesome.
It is freaking awesome.
It's awesome, and it's
yeah. I mean, it's a scientist and clinician's dream to see such a striking result.
Absolutely.
Yeah.
Absolutely.
All right, moving on.
Okay.
Second breakthrough from April 2025. This was also very striking.
Very, very striking. So the next one is about the shingles vaccine. This was, maybe some people have heard about this because this was on the BBC. I saw it on BBC. I think my dad talked to me about this.
Oh, good. So people
which shows
know.
that it broke through. This one firmly broke through into the general population. And so it's about the shingles vaccine and dementia.
What do those two things have to do with each other? They seem completely unrelated.
Absolutely. So, before we start, just a bit of context. So the global total burden of dementia is increasing. That's true because we're getting older.
Yeah.
But the individual risk of dementia now is much lower than it used to be. So someone's if you're 80 today versus if you were 80, let's say 40 years ago, your risk of dementia now is much lower, much lower. So even though the absolute burden is increasing because there's more people and because we're getting older, the individual risk is actually much lower.
Yeah. When you compare it at the same age, like
yes,
however many years ago.
Age. So the question is, how can we keep that trend going? How can we keep driving down the burden, the individual risk of dementia? And maybe this is one. So this is an experiment that shows that the shingles vaccine reduces the risk of dementia by about 20%.
And, it's such an interesting setup because my question to you is, how did they even think to look at how these two things are related, shingles vaccines versus dementia?
That's a good question. I don't know. I don't know. I think I don't know. It's a good question.
Yeah. I think there are some other studies in the field showing maybe some other like herpes virus or viruses like can lay dormant and cause some other neurodegenerative diseases that are unrelated to the original condition is known for.
Yeah.
And like how were they able to like study this? And this is also part of the reason for why this study was so interesting.
Yeah, exactly. So it uses a very nice, what they call a natural experiment from Wales.
What's a natural experiment?
So this is where it's not like set up to be an experiment. We're not designing the experiment kind of prospectively like a randomized trial. We're just looking at the data and where nature has kind of produced its own experiment for us.
So basically it's already happened, but you're just looking at what happened and the
exactly.
data.
So for this one, there was a very nice coincidence where in Wales, in 1933, if you were born the week before the 2nd of September 1933,
Yeah, so 2nd of September.
then you what is it?
You're eligible for getting the vaccine
Yes.
like after this date, but you're not
Yes.
eligible if you're born before.
Yes.
Yeah. Or is it the other way around?
Yes, sorry.
No,
So
no, it
those-
is that way
so
around.
those-
Yeah. There you go.
So those born in the week before the 2nd of September 1933 were ineligible for the vaccine, the shingles vaccine. But those in the week after that date, they became eligible, and they were eligible forever. And so these two groups of people are effectively the same, right? So if you were born the day before the 2nd of September or the day after, there's no reason to believe they're different at all. There's only a few hours of difference in age between
It's
them.
not like you're years apart in age, and
Exactly.
there's like a whole, it's like such a perfect control, like such a clean cutoff point
Yeah.
because of like the government or whatever policy was imposed.
So these patients are effectively randomized. They're effectively equivalent and identical and the same, with one exception, and that's shingles eligibility. And so if you look at the difference in dementia risk moving forward, so they had the vaccine when they were 80, by the way, so much further on than 1933, and then those who were eligible and vaccinated had a much lower risk. So, and this has, just to talk about the mechanism as well, right? Because this could, the question of why shingles vaccine would reduce the risk of dementia is an interesting question,
It's
right?
so interesting, and there's so many hypotheses. And just to say, like, that cutoff was made, the uptake of vaccines did go up to 47%. So it wasn't like they were eligible for the vaccines and didn't take the vaccine, but they actually had it. So,
Exactly.
the researchers made sure that there was no other policy or regulation change during that week as well that could potentially become a confounding factor.
Yeah, and they did a great job of making sure there were no potential confounders that could explain these results, with the exception of the shingles eligibility.
Yeah, exactly. Which makes it like a perfect experiment.
It's really, they call it a kind of quasi experiment or a natural experiment. It's quite nice. So, in terms of the mechanism, so what shingles actually is. So most of us, have you had the chickenpox vaccine? Is that
yes,
you
I
have?
did, and I
So
had it in Hong Kong or States.
So you haven't had chickenpox?
No, I haven't.
So I have.
You have it.
I've had. So in England, we don't routinely vaccinate for chickenpox, which means that I have had chickenpox, and therefore probably the chickenpox virus
it's still dormant.
is hanging around somewhere in my nerves.
Ooh, it's creepy when you say it like that.
And later on, if my immune system dips for some reason, then the chickenpox virus can reactivate as shingles. It's the same virus, right? So the chickenpox childhood virus.
Is it VZV?
Varicella zoster.
Yeah.
So you can never get shingles. You haven't had chickenpox, you can never get shingles. I can. So it could be, therefore, that shingles itself causes dementia.
That's one hypothesis.
And indeed, we know that shingles hangs around in nerves. There are nerves that come out of the brain. There are nerves in the brain. So it could make sense that the virus itself inflames nerves and causes dementia that way.
That makes complete sense.
It could be other things as well, right? So it could. There's a theory that it could be a shingles independent benefit of the vaccine. So the vaccine might be kind of somehow suppressing inflammation, irrespective of shingles, and that reduces the risk of shingles. That's a possibility too.
Yeah, just because, some vaccines, they have off-target effects, not in a bad sense, but in a beneficial sense, that once it kicks up your immune system, it's not only targeting that virus that it was designed for, but it's also getting your immune system to be more alert, and it gets rid of other conditions such as dementia.
Exactly, yeah. So it could be, that's the second theory. The third potential theory is that people who get shingles get treated for shingles, right? So they may get things like, they actually often get a lot of pain. So shingles causes a kind of blistering, painful rash, which is in the pattern of the dermatome. So
what's dermatome?
So the nerves supply the skin, and when I touch here, for example, that's me. That's sensed by a nerve that comes out of my spine.
Yeah.
So individual dermatomes in the skin, like independent parts of the skin, are supplied by independent nerves. So that's what shingles doing. It's reactivated in dermatomes in the skin.
Wow.
And so it's painful.
Yeah.
And so people get treated with things like codeine or opiates. And it's possible too that opiates might increase the risk of dementia or indeed kind of tip people into dementia. So that's a possible...
So it's like the follow-up of treating shingles that might lead to dementia.
That's another possible explanation. But I guess the bottom line is we don't know how it's working. It's one of the above.
Because like, you know, kind of proving this link itself is already amazing because, you know, previous studies that tried to show this link, there were so many confounding factors because people who are willing to get the vaccines, they might also be likely to be healthier.
Like healthy vaccinee bias, right?
Yeah, yes. Exactly. And that's why it was so hard to prove. And that's why this is so serendipitous.
Yes.
And as a perfect control.
And there were plenty of criticisms about this paper, but I want to say as well, this has been... So these authors did an awesome job of suppressing confounders. By the way, I should say that these guys are in Stanford University.
And this was published in Nature Medicine?
Yes, exactly. Nature. But since there's been a replication of the study in a different population, so in Australia, by different authors in a different journal, and they find the same thing.
Do you know if it's the same vaccine or if
it's the same vaccine?
Exact same, because I realized that
there's a couple,
two vaccines, because you know that would be a great way to use a new shingles vaccine and see if you see the same effect. Because if you do, then you know it's something specific to shingles maybe and not a general immune effect.
So there is a study, or more than one study, using the other. So this is with the live attenuated shingles vaccine. There's a different shingles vaccine, which is a recombinant vaccine. And in a different study, which is less good than this one, but still pretty good, that also reduces the risk of dementia.
That's great.
So
it's not a general immune thing.
Exactly. That increases the probability that this is a real effect, firstly, and two, maybe this is because we're suppressing shingles. The other thing is that, so dementia is clearly such a problem, right? But vaccinating people for shingles and reducing individual risk by 20% could have a huge impact, right?
20%, a fifth. That's huge.
On ongoing. So I think that's in terms of preventative medicine as well, which is what I like most. Yeah. This is fascinating for that reason too.
Yeah, and it's obviously been picked up by the press, so people realize the significance of this, especially as you mentioned, dementia is a huge burden socially, and just on the economy as well. And I think there's a crazy stat that like every second or minute that passes, one new person gets diagnosed with dementia, and it's probably underdiagnosed as well. Yeah.
So, and the other thing is that once dementia is set in, it's extremely difficult to treat. Really, there's no effective therapies. I think it's fair to say there's no effective therapies to slow down the progression of dementia.
Yeah.
So we need to focus on prevention.
Exactly, and this is perfect way to do so. Yeah. So yeah, maybe like, you know, everyone should go get a shingles vaccine.
But I wonder what it's like in populations who have never had chickenpox though, right? I mean, we should be able to do, there should be some study done.
Maybe we should do a systematic
review. You want to do a study? Should we do it today?
Everyone, you heard it here first.
I mean, that's,
Yeah, it is interesting because I think I got it in the States because I grew up in the States and Hong Kong, and I got jabs in both places. And I think this was mandated in the States. Yeah, when I was like, I got it when I was 1 or 2.
Yeah. So, but it's funny, isn't it, that we don't do the vaccine routinely here? But
yeah, there you go. Like, you know, health policies, it really affects people's lives.
Absolutely. So interesting. Should we move on?
Yeah, that was great, Sam. Gosh, I leave the UK for a few weeks, and this is like all over the news. So wow, this one blew my mind. And you're gonna have to help me and the audience explain a lot of acronyms that sound like each other.
I have to turn my brain on now. Okay, here we go.
Same here.
So I got it. First thing to say, so it's in this one is in. Oh, I'm going to cite it live actually. So it's in the New England.
Have you got the actual?
I got it. It's in the New England Journal from the Crick
Ah,
in London. So let me cite it live.
I love that you have these
There we go.
subscriptions.
Here's the citate. This is my picture towel.
That'll be the icon or the thumbnail for this episode.
Okay, so now you're right. This is a bit more maybe cerebral, a bit more difficult to understand,
But I think
bit
it's
more acronym heavy.
I think it's great for the audience, especially those who like to challenge themselves with these terms. And you get to sound really smart at these dinner parties when you talk about, was it tumor infiltrating clonal hematopoiesis?
Yes. So it sounds complicated, but it's of profound importance. Really, and it's potentially treatable. So okay, as we get older, a number of things happen.
Gray hair.
We get grey hair. The immune system starts to decline. Inflammation happens, kind of chronic, systemic, subclinical, low-level inflammation. Mm-hmm. That increases your risk of having a heart attack or a stroke because it causes plaque formation in arteries. Mm-hmm. There's also an increased risk of cancer, both solid cancers and liquid cancers, as we get older. And this is a mechanism which ties together all of those things. And on top of that, it's treatable. So
exciting. That was a very good setup.
What I'm potentially suggesting,
I'm listening to every word now,
is that if we treat this, we can be treating aging, inflammation, heart attacks, strokes, cancer, through the same mechanism.
You've got everyone's attention now. So what is this?
So the name of this process is clonal hematopoiesis of indeterminate potential.
So this stands. The short form of this is CHIP.
CHIP. So I have an issue with the name off the bat because they say indeterminate potential, but the potential is inflammation, heart attacks, strokes, cancer, immune decline. Right? It's not indeterminate potential. The potential is determinate, and there's a number of potentials. The reason
maybe we can just call it CHP.
Clonal hematopoiesis of potential. The reason they call that is there is a good reason for that. Anyway, but so what it is we have hematopoietic stem cells in our blood that replenish blood cells
in the bone marrow.
And as we get older, most of us will accumulate a mutation in these stem cells. More than 50% of us by the age of 80 will have a mutation in the stem cell.
Yeah, just as our telomeres get shorter over time as we age, this CHIP happens.
Exactly. CHIP happens to most of us by the age of 80. That has a few consequences. The first one is that it means that myeloid cells are more likely to be produced. So things like macrophages are getting produced at the expense of lymphoid cells like T cells. So we're making loads of mutant macrophages and fewer T cells as a result of this mechanism.
I see. And just back to the basics of it for the audience. This is, myeloid cells, they include like macrophages, and they do a separate job. They're part of the innate immune system. So they're very different to the adaptive immune systems, which include things like T cells.
Exactly. So we know that as we get older, the adaptive immune response declines. Mm-hmm. Right. So the adaptive immune response is this kind of specialized one, the long-term memory one. Right. So we have T cells, which are specific for things. We have B cells, which make antibodies.
Yeah. So those are like really honed in on a certain target, whereas like innate is just like a general response to anything that's causing problems in your body.
So what this is doing is making more of the general response at the expense of the specialist response. So it's not good. The other thing is that it's producing these mutant macrophages, which are inflammatory. Mm-hmm. So what that means, if it's causing this kind of systemic inflammation, the low-level activation of the immune system that causes inflammation, which is causing this plaque formation in arteries, and which is causing cancer as well. And that's the particular bit that's new here.
I think it's a beautiful unifying way of looking at, a lot of people, even like outside of science, people know that we have chronic inflammation is the cause of all these diseases that you just named that people uh, get higher risk for as they age, like cancer and like heart attacks and all those lovely things that we're gonna
Yeah.
have to face.
But the good news is that it's targetable, right? So those one of the things that these mutant macrophages produce is cytokines called, so there's two important ones, IL-1 and IL-6.
And these are, correct me if I'm wrong, because I'm not an immunologist, but these are inflammatory molecules secreted by these macrophages. And yeah, they lead to this like low level
Yes.
chronic inflammation, right?
Yes. And this is extremely important. It turns out that if you inhibit IL-1 and maybe IL-6, there's emerging data, but IL-1 definitely with an antibody, monoclonal antibody, then you suppress inflammation. Your risk of having a heart attack is lower. Your risk of having a stroke is lower. And your risk of cancer is lower.
That is amazing. And is everyone taking IL-1 now? Are they drinking it?
No, so it didn't. That's fascinating, right? It didn't get approved.
Why?
So it went through FDA. It went through the phase 3 trials. It went to the FDA. They said no. They did not approve it because there is an increased risk of severe infection. So fair enough. But there's the IL-6 one might be the one to go for, and that's going through trials.
It's so hard to modulate these things. It's just like you want the good side of like the immune system, like the innate, because the innate immune system does do a job. It has a function, but when you try to get the benefits of blocking it, then it's like a seesaw. Like you have to balance.
You have
both
to be
sides.
you have to be so careful, right? And so IL-1 unfortunately isn't the target.
That's a shame.
Maybe IL-6 is the target.
Yeah. So fingers crossed for those. Are those in trials right now?
IL-6 is in trials.
Okay.
And the other thing that these guys show is that these mutant cells are actually making their way into the cancer. So, and not only...
Hence the infiltrating.
Exactly.
That's what it means. It's infiltrating from the bloodstream into the actual tumor.
Exactly.
Yeah.
So that's why they call it tumor infiltrating clonal hematopoiesis. And they're getting into cancer, and they're not getting into every cancer. They're actually getting into the most aggressive ones. So lung cancer, pancreatic cancer, head and neck cancer, and they are making the cancer worse and more aggressive.
And it makes sense. It's like, I guess that's incentive for why these researchers wanted to ask, how is it making the cancer worse? Or, is it true that like cancers that are aggressive have more of these infiltration? Yeah,
exactly. And that's what they show. So in terms of, I think it's like I say, it's an extremely important unifying mechanism that unifies so many important things that happen as we get older. So aging, inflammation, immune decline, heart attack, stroke, cancer. It unifies all of those things, and it's potentially targetable. So it's true that if you use things like IL-1 or IL-6 blockers, you're not going to fix the source problem, because the source problem is a mutation in a stem cell.
But you fix it like somewhere in the middle.
Exactly.
Like before, it's like the mutation causing the cytokines to be released and then causing the issue. So you're fixing it at the cytokine level.
Exactly. So, and if we were able somehow to fix the mutation in the first place, which is what more than half of us have when we get to the age of 80, then that would be even better.
Yeah, we'll reduce the risks of all these things.
Exactly.
And I guess, what I really liked about this study, it shows in a huge cohort of non-small cell lung cancer patients in the TRACER-X study, that 42% of those with CHIP also had this infiltrating the hematopoiesis. So it shows that immediately it correlates having CHIP with having this tumor infiltrating phenotype.
Yeah, exactly. I mean, this is a completely novel concept in cancer biology as well, by the way. This is totally new. The fact that these cells can get into tumors and interact with the tumor, interact with the microenvironment, and make them more aggressive is totally new.
Yeah, exactly. And then they showed that like when you do have that this determines the outcome of response of these non-small cell lung cancer patients as well, and that if you do have this condition, then it's 2 years versus 6 years of recurrence for the outcome.
So it makes a big. Do you want me to show a Kaplan-Meier?
Yes, please. I'll make sure my head's not in the way.
So, okay, here we go. So we're talking about. I'm not sure how good this is.
You have to like hold it really still, and then we're gonna crop it.
So this is patients, like you say, with non-small cell.
I can see the gap from here.
Non-small cell lung cancer. The ones in blue don't have CHIP.
Mm-hmm.
The ones in red have CHIP, where so tumor infiltrating CHIP, where the cells are getting into the cancer, and you can see that the survival is much worse.
Yeah, it's so clear from here as well.
Yeah.
And they tried to see whether this is true in all sorts of other cancers. I think they looked at close to, after this Tracer X study in non-small cell lung cancer, they then did a pan-cancer study in around 50,000 patients, which included like 70-something different cancer types. And they found that actually different cancer types have different prevalence of this infiltrates.
Yeah.
Not all cancers have this high of a rate. So it begs the question of like, why do some of the, especially aggressive cancers, have this TICH and some others don't?
Exactly. Yeah, exactly. Interesting question.
Yeah. Why does the tumor microenvironment of some cancer types, especially those aggressive solid tumors, attract more of these mutated myeloid cells, and some other ones don't?
Exactly. That's the question.
Yeah.
That's the question. How can we stop this happening? And how can we harness it to treat the cancer too?
This paper is huge. It just linked so many like conditions and like dynamic pathways together. It really shows you that like a lot of these chronic conditions we are managing it's not just one thing. It's like multiple things happening at once. And it takes like Herculean effort to tease it all apart.
Absolutely, yeah. I mean, I think that the concept of the phenomenon of inflammation as we age is one of those things that's driving so many different conditions, and also caused by so many different risk factors. I mean, so obesity causes inflammation, type 2 diabetes causes inflammation, smoking causes inflammation, right? And inflammation causes cancer, causes heart attacks, causes dementia, by the way, right? So lots of these things are linked together. The interesting bit, the good bit, is that if you avoid those risk factors, if you avoid smoking, if you avoid obesity, if you avoid diabetes, then you can, all at once avoid so many, or reduce your risk of so many different conditions.
Yeah, it makes sense, which goes back again to prevention and managing lifestyle. So yeah, I think we need to come up with like a little quote or motto. We keep saying like prevention is better than cure.
Yeah.
Who said that? Erasmus?
Who said that? Is that?
It's a famous quote, like prevention is better than cure.
Yeah. Was that Erasmus? Was he a doctor? Was that?
Let me Google it.
I did Erasmus, I'm writing a article about prevention and about how to live longer.
You are?
Yes. I'm working on it.
You have to show it to us once it's out.
Yeah, I will. I'll promote it.
Yeah, we need like an episode dedicated to like the papers we published this year.
Did you Google Erasmus?
Yes, I did. Okay, I don't know how much we can rely on the internet, but apparently he did say it. Don't know if it's an internet thing.
All right, good.
But with that, wow, that was an amazing April.
Just do you want us to just quickly summarize each of the three things?
Yeah. So, in this episode, Sam and I talked about the three scientific or medicine breakthroughs. The first being a colorectal cancer metastatic MSI high setting, where now FDA has approved a novel doublet immunotherapy first-line treatment, and it's huge. With the response rate, 70% versus 14%.
Yeah.
So that was the first one.
Amazing. Second one was about how we may be able to reduce the risk of dementia with the shingles vaccine.
And then the third one, would you like to do the honors?
The third one is, I would just say, it's a mechanism that ties together so many important things that happen as we get older. And it's brand new discovered. It increases the risk of cancer, it increases the risk of heart attacks, it increases the risk of strokes. And it's very important and potentially targetable.
And all linked through inflammation and myeloid cells.
Yes.
Excellent.
Awesome. Thank you, Tiff.
Thanks,
nice
Sam.
to see you.
See you next time for what are we talking about next time? Biotech deals and startups.
Yeah.
We'll see you next time on Sam and Tiv Talk Science.